Everyone, and welcome to today's Kata. This one this one was a bit iffy for me. When I first saw the problem, I honestly thought it was going to be very easy to solve and straightforward, and it actually is to some extent. The only thing is the rules that revolve around this algorithm they are supposed to write is what makes it a bit tricky. So if you don't understand exactly how you structure your pseudocode or your approach, it might take you a bit of time, as it did take me. Because it took me, I thought it would take like a little bit of time, but I didn't expect it to take a few days. So this is the basically, let's just read through it so that you get. Let me show you where the whole thing became a bit iffy for me. So it says define a function that takes one integer argument and returns logical value true or false depending on if the integer is a prime. Per Wikipedia, a prime number, a natural number, is greater than 1 that has no positive divisors other than 1 on itself. So these are the requirements. You can assume you'll be given an integer input, so there won't be any other data types. You cannot assume the integer will only be positive, so technically you could be given negative numbers or 0. Note on performance, there are no fancy optimizations required, but still the most trivial solutions might time out. Numbers go up to 2 raised to the power of 31 or similar. Depends on language version. Looping all the way to n or n divided by 2 will be too slow. Now this is where everything becomes tricky, because I had like 2-3 different solutions that solved the problem for the lesser test. But when we had tests that went up to this massive number, 2 raised to the power of 31, that is where my solutions were failing. So without this solution, the solutions I had were failing because they involved looping up to this or around this. So obviously from this statement, you know that it would fail. So it's just, I didn't fully understand the problem, hence my approach was skewed. But as soon as I did understand, as soon as I found a way to understand the problem or how to solve it, I solved it in like 3 to 5 minutes, something that took days previously. So sometimes it's your understanding of the problem that will determine whether or not you can solve it or whether you won't be able to. So now what helped me is I went to the comment section of this particular problem, and then I saw a hint. The person did, all I got was a hint, SQRT, meaning square root. That's the key to solving the problem. So when I got that, I just googled. I said, okay, square root prime numbers algorithm. Then I found this article that described, is on this site. I'll link it in the description. It's on this site. It describes how to find prime numbers, how to discover or how to decipher if a number is prime. So it says this the hard way. Technically, this is not like a programming solution. It's just a way to check it. But it's basically pseudocode to me, because as soon as I read it, I understood how I could solve the problem. So you write down a number you wish to test to see if it is prime. Find the square root of the number you wish to test. I'm not going to read through everything, it's a bit long, but if you can, I'll link the article. If you come here, you'll be able to see why I was able to solve it using this. But basically, this part of it, this is the hard way. Before this other header here, that was what should give me the insight on how I can solve it. So let's just dive in and write some code. And by the way, I'm now on 7KYU. This was the problem that I helped to solve, that helped me to get to 7KYU. So let's just get right in and write some code. So the first thing I did is I declared a variable called num square. Yeah, which is basically the square root of the number that is passed. And that was the first step. Then, as per the instructions, numbers that are negative or 0 was not meant to pass. So I just wanted to have a simple if statement here that would disqualify all those numbers. One is also my prime number, so that helps with that too. So then the solution I'm about to implement, it also doesn't really favor the smaller prime numbers, so I just wanted to eliminate those as well in one if statement. So if none equals to 2 or none equals 3 or none equals to 5 or none equals to 7. So number is equals to any of these prime numbers that are less than 10. I just wanted it to be disqualified, okay, to be approved rather, since they are prime numbers. Yep. So that's for this. Then, as per the description in that article, if a number has a square root, is like if it has a perfect square, what they call it in math, it shouldn't pass the test. So I just had a simple test to disqualify all those numbers, which is if number modulus num square equates to, so basically if the number equates to 0 here, I want to return false. Then this. Then I want to create a for loop. We're starting the for loop, the initial expression from 2, because 1 is not going to go as we want. So in I less than num square, right? Then I incremented. So this is our for loop. I want to say if number that is passed in modulus I equals to 0. Okay, this is supposed to be less than or equals to num square. So if any of the numbers are iterating from 2 all the way to num square equates to 0, it means that that number that was passed in has a factor pair within this range, and if it has a factor pair, it's not a prime number. So we want to return false. Then this for loop, I want to have another one quickly here. So let it equate to 2. So and I less than equals to num square and I plus plus. So yeah, if statement real quick. Modulus I, all the iterations is not equals to 0. I want to return true. Yeah. So this is the solution. Let's give it a test and see. Ooh, I is not defined. That is prime. What's the problem? Oh yeah, there's a mistake here. It's I equals to 2. Did I not define it somewhere else? Oh yeah, let's see. Oh yeah, so we passed the basic test. The tricky one is here, so let's give it a try here and see. So yeah, that's it. That's how I solved the problem. I know more experienced programmers look at this and cringe, but like I always say when I solve these problems, this may not be the most optimal one, but this is the solution that helped me to solve the problem as at when I took the challenge. So thank you for watching. Stay tuned for more Kata challenges.